Okay, Assalamualaikum warahmatullahi wabarakatuh. And now we come to Fourier series. Okay, actually this is the general formula for Fourier series. Okay, we have fx equals to a naught over 2 plus the sum of an cos n pi over p x plus bn sine n pi over p x from n equals to 0 to infinity. Okay, whereby a naught, okay, we have the formula 1 over p and the integral of fx dx from negative p to p. Okay, this is the formula for a naught. And for an, the formula is 1 over p, the integral of fx cos n pi over px dx from negative p to p. Okay, this is the formula for an. Okay, then for bn, the formula is 1 over p, the integral of fx sine n over px dx from negative p to p. Okay, this is for bn. Okay, the difference between an and bn is an we have cos, for bn we have sine. Okay, all this formula will be given during the exam. Okay, now Fourier cosine and sine series. Okay, if we have even function on the interval negative p to p, so to compute a naught, we have the formula 1 over p, the integral of fx dx from negative p to p. Okay, remember the even functions, the graph for even function. Okay, let's say we have this curve. Okay, absolute x curve. This is the graph for even function absolute x. Okay, the integral is area under the curve. Here from here negative p, and here positive p. Here 0. This is y, and this is x. Okay, the area here equal the area this side, the same unit. Okay, so we can compute the integral from 0 to p and multiply by 2. That's why here 2 over p, and the interval here from 0 to p. Here from 0 to p, because this area same with this area, so we can multiply by 2. That's why 2 over p, the integral of fx dx from 0 to p. This is for even function if our fx is even. Okay, for an, okay, to compute an, okay, the formula is 1 over p, the integral of fx cos n pi over px dx, the interval from negative p to p. Okay, we know that our fx is even function, so even function. Okay, and cos. Okay, cos, how do we know it's even or odd? Okay, you can use your calculator, try to compute cos 30 and cos negative 30 degree. So you will have the same value, right? Okay, so remember from the definition, f negative x equals to fx. So f cos negative 30 equals to cos 30. So the cos always even function. So cos is even function. So cos is even. Okay, so even time even, the product is even functions. So for even functions, okay, same here, same with this. So for even function, so we can multiply by 2 since the area is same, and the interval we can change from 0 to p. Okay, the interval you can change from 0 to p instead of negative p to p. So here the from 0 to p instead of negative p to p. Okay, so for even function we can compute a naught, an, and for bn the formula is 1 over p the integral of fx sine and pi over px dx, okay, from negative p to p. Okay, we know fx is even, and sine. Okay, for sine, okay, you can use your calculator. Sine negative 30 and sine 30. Okay, we will have the different value but different, we will have the same value but different in sign. Okay, so f negative x will be negative fx. This is for odd. So the sign function always odd. So even times odd, the result is odd. So for odd function, the integral of odd functions always be 0. For odd function always be 0. Remember from the previous part for odd function. Okay, let's say we have this curve for odd function. Okay, this 0, dia negative p, and here p. Okay, the area here, this is, we have negative value, and here we have positive value. So let's say we have a, this area, this is a and this is b. So a plus b will equals to 0, right? Positive value with the same, negative value with the same unit plus positive value with the same unit, so it will equals to 0. So that's why the integral of odd function equals to 0. So for even function, if our fx is even, so you just need to compute for a naught and an, because bn will always be 0. Okay, that is for even function. Okay, now for odd function. Okay, if our fx is odd function on the interval negative p to p, okay, our fx is odd. So, okay, the integral of odd function will always be 0. Okay, then we move to an. Okay, for an, okay, our fx here is odd, and cos always even. Odd multiply with even will become odd. So the integral of odd function will equals to 0. So our an and bn, or an and a naught equals to 0. Then we move to bn. Our bn is 1 over p. Okay, fx is odd, and sine also odd. So odd multiply with odd, we get even. So for even function, so we can compute for bn. Okay, we can multiply with 2. So but the integral we change the limit from 0 to p. Okay, so for odd function, we only have Bn since a0 and an equals to 0. So this is the Fourier series for odd function. Okay, with this is for Bn, the formula for Bn. Okay, this formula will be given. Okay, example. Okay, example. Okay, if we have fx equals to absolute x, x greater than negative pi, less than pi. Okay, expand the given function in appropriate cosine or sine series. Okay. The question asks you to expand the given function in an appropriate cosine or sine series. Okay, here we have fx equals to absolute x. Okay, this absolute x, okay, we have a graph for absolute x. Okay, this is the shape of the graph. So this is y-axis and this is x-axis. So the graph is symmetric about y-axis. When the graph is symmetric about y-axis, so the function is even function. Even function. So the Fourier series for even function, here we have fx equals to a0 over 2 plus the summation of an cos n pi over p x n equals to 1 to infinity. Okay, this is the Fourier series. This is the Fourier series for even function, or we call Fourier cosine series, because here we have cos. Okay, first we need to compute for a0. Our formula for a0 is 2 over p. Okay, since this is the even function, so we can multiply with 2 over p. Okay, the interval from 0 to p fx dx. Okay, so 2 over p okay, actually p here is, this is negative p and here is p, so our p is pi, 2 over pi, and the integral of fx from 0 to pi. Our fx is, okay, since from 0 to pi, so here 0 and here pi, here negative pi. So from 0 to pi here, the function is fx equals to x. So x dx. Okay, so we can integrate. Okay, so 2 over pi, integrate x, we get x squared over 2. and here 0 and pi. So we can substitute x with pi and 0. So we get 2 over pi. Okay, substitute x with pi. Pi square over 2. Then substitute x with 0. So 0 over 2 is 0. So 0 minus 0. Okay, here we can cancel 2 and pi as well. So we have a naught equals to pi. So our a naught equals to pi. So this is our a naught. Okay, then we want to find for an. The formula for an equals to 2 over p fx cos n pi over p x dx. Okay, from 0 to p. Okay, our p is pi. Okay, 2 over pi 0 to pi. Our fx is x cos n pi over p. P is pi and pi over pi x dx. So we can cancel pi. We will have 2 over pi x cos n x dx from 0 to pi. Okay, so since here we have two functions, x and cos and x, so we can use integration by part, IBP, or the most simple one is tabular method. Tabular. Okay, I prefer tabular. So refer to this formula, Layet. So algebra and trigo. Algebra come first. So our u is x and dv is cos and x. So our u here, our dv. So our u is x and our dv is cos and x. Okay, for u we differentiate and for dv we integrate. It is stable. We make a table. Okay, we differentiate x, we get 1. We integrate cos and x, we'll get 1 over n sine sine 1 over n sine and x. Okay, then we differentiate 1, we get 0. Then we integrate 1 over n sine n x, we will get negative 1 over n square cos n x. Okay, remember we have to cross multiply. Okay, these terms. Okay, remember the sign, plus minus plus here. So you have the an equals to x over n sine n x. Okay, minus here, here also minus. So minus become plus. So plus 1 over n square cos n x. Okay, remember you have 2 over pi in front. Okay, and the interval 0 to pi. Okay, so you can substitute. Okay, 2 over pi. You substitute x with pi. So pi over n sine n pi plus 1 over 2 cos n pi. Then we can substitute x with 0, so 0, so it's become minus 0 minus 1 over 2 1 over n square cos 0. Okay, look at here, we have here sine n pi. Okay, you know the graph for sine. We have the graph for sine. The sinusoidal. Okay, we have here 0, pi, 2 pi, 3 pi, 4 pi. This is for sine. Okay, when sine pi equals to 0, sine 2 pi also 0, sine 3 pi equals to 0, sine 4 pi also 0. So we can conclude sine n pi equals to 0. So sine, this is sine n pi, so equals to 0. And then we have cos n pi here. So cos n pi, we have the graph for cos. Okay, this is pi. This is 2 pi, 3 pi. Okay, this is for cos. Okay, so cos pi equals to minus 1. Since here, minus 1. So cos, then cos 2 pi equals to, here 1 equals to 1. Cos 3 pi equals to negative 1. Then cos 4 pi equals to 1. So cos n pi equals to negative 1 power n. Okay, we can check. If n equals to 5, so cos 5 pi equals to negative 1 power 5 will be negative 1. Cos 5 pi equals to 1, so cos 5 pi equals to negative 1 sign, since it's alternate, negative, negative, positive, negative, positive. Okay, so that is correct. Okay, so here we have cos n pi equals to negative 1 power n. So 2 over pi. Okay, since sine n pi equals to 0, so the whole becomes 0 plus 1 over n square. Here actually n square. 1 over n square negative 1 power n minus 0 minus 1 over n square, since cos 0 is 1. Then 2 over pi negative 1 power n minus 1 over n square. Okay, this is for an. So we have our an is 2 over pi negative 1 power n minus 1 over n square. This is our an. So we can substitute to the Fourier series. So fx equals to pi over 2, since our a naught is pi, so here pi over 2 plus, okay, the summation of 2 over pi. Okay, this is for being n. 2 over pi negative 1 power n minus 1 over n square cos n pi over pi x. Okay, pi here we can cancel. So we have pi over 2 plus summation of 2 over pi negative 1 power n minus 1 over n square cos nx. Here n equals to 1 to infinity. So that's it. Thank you.